You know that feeling of being just completely overwhelmed by your digital files.
Oh, yeah. The digital clutter.
Right. You sit down at your computer, you open your email inbox, you look at your desktop, and it is just this sprawling, chaotic
Well, there's
mess.
a sea of icons.
Exactly. A sea of unread messages, poorly named documents, final version v3, really final.pdf.
We've all been there.
Yeah, you're drowning in information, and the sheer volume of it feels, well, it feels paralyzing.
It really does.
But I want you to imagine facing that exact same feeling of information overload. But instead of lightweight digital files, your hard drives are quite literally made of baked mud and sheepskin.
Which is just, I mean, it completely shifts the perspective on what data actually is.
Right, because it's physical now.
Exactly. When your information has physical mass, the problem of how you organize it isn't just a matter of convenience.
It's not just a neat desktop aesthetic.
No, it becomes a matter of like architectural physics. You're dealing with load-bearing walls and sheer human endurance.
And that is exactly our mission for today's deep dive. We are going into the foundational architecture of the digital age.
But we aren't looking at the 1990s.
No, not at all. We're not talking about the invention of the silicon microchip or, ARPANET. We are exploring a fascinating reality. Long before computers, fiber optics, or the internet ever existed, humanity was already building the conceptual architecture of our modern digital world.
It's incredible to think about.
It really is. We're going to uncover how ancient scribes, cloistered monks, and early librarians constructed the very first true information networks.
Because what we are really looking at today is the fundamental logic of human knowledge.
The actual underlying structure.
Yes, the struggles those ancient archivists faced, how to structure, how to store, and critically how to retrieve information, those are the exact same logical problems that dictate how our modern relational databases work.
How our search algorithms and cloud networks function.
Precisely. The underlying cognitive architecture was laid down millennia ago.
So let's travel back to the 4th millennium BCE. We're going to Mesopotamia.
Ah, the Sumerians.
Yes, the Sumerians. This is the absolute dawn of systematic knowledge preservation. They utilized cuneiform script, but they didn't write on paper.
No, paper was a long way off.
Right. They impressed this script into wet clay tablets, which were then baked in kilns or dried in the sun just to ensure they survived.
And it's crucial to understand the mechanics of this, They weren't just jotting down random fleeting thoughts.
It's like ancient tweets.
Right. No ancient tweets here. These tablets contain the absolute bedrock of a complex civilization. We're talking economic transactions, legal codes, literature, astronomical observations.
Basically the data required to run an entire empire.
Exactly. And the medium they chose, the clay, dictated the terms of how that data was handled.
I always look at these clay tablets as humanity's, early generation ruggedized hard drives.
That's the great way to put it.
Because a clay tablet is incredibly durable. I mean, we are still digging them up today, completely intact, thousands of years later.
Yeah, you definitely can't say that about a floppy disk from 1995.
Oh, absolutely not. Those things corrupted if you just looked at them wrong.
Yeah.
But as a hard drive, clay is heavy. It is physically cumbersome, and the read-write speed is agonizingly slow.
The latency is off the chart.
Think about it. If you want to update a legal code or record a grain transaction, you can't just hit backspace.
No, you have to locate raw material first.
Right, you go get mud. You wet a new slab of mud, you impress wedge-shaped marks into it with a reed stylus, and then you have to bake it.
The write speed of early civilization was literally dictated by the temperature of a kiln.
Which is wild.
It is wild. And that physical friction, that slowness, is precisely what forced the invention of the database.
Wait, how so?
Well, because writing a single tablet was such an incredibly resource-intensive process, the resulting data was highly valuable. You don't go through the trouble of baking a mud spreadsheet just to toss it in a corner.
Right, you're not going to lose that.
Exactly. They deliberately collected these tablets in temple archives and royal libraries. And they didn't just stack them randomly, They implemented rudimentary categorization based on subject matter.
So they created physical folders.
Yes. This is the exact moment humanity invents the concept of the centralized database as a tool for administrative power.
So they're putting all the economic transactions in one room, all the legal codes in another, and astronomical charts in a third.
Creating a system of organized retrieval. Because it wasn't just about keeping a record, right? It was about being able to find that record 5 years later to enforce a law, or collect a debt, or predict a flood.
They were removing data from the fragility of human memory.
Placing it into a structured physical architecture.
But I mean, clay has a hard limit, doesn't it?
Oh, absolutely.
You have these heavy, ruggedized mud hard drives in Mesopotamia, but as the civilization scales up, the physical weight of that data just becomes unmanageable.
It doesn't scale well at all.
Right. You can't carry a library of clay into battle, and you can't easily transport it across a massive, sprawling empire.
The logistics of that would be a nightmare.
So the physical medium has to evolve. And that shift happens in ancient Egypt, where they start using hieroglyphic and hieratic scripts. But the real game changer is the medium itself.
The papyrus scrolls.
Yes, papyrus.
The shift from baked clay to woven reed papyrus is an absolute revolution in information technology. It fundamentally altered the bandwidth of human communication.
It's essentially the invention of the portable flash drive, isn't it?
I love that analogy. It really is.
Suddenly, you have a medium that is lightweight, it's flexible, and it's capable of holding continuous files. You aren't limited to the physical dimensions of a heavy mud brick that has to fit in your hand.
Right. You can just glue sheets of papyrus together and roll them up and keep going.
And because of that physical flexibility, the nature of the data being recorded could expand dramatically, right?
Dramatically.
Yeah.
Egyptian scribes could now meticulously record these extensive narratives that would have required, like, a wheelbarrow of clay tablets before.
So what kind of texts are we talking about here?
We start seeing complex religious texts, like the Book of the Dead. We see detailed medical treatises that document actual surgical procedures.
Wow.
Lengthy royal decrees, sweeping historical accounts. The scroll allowed for this continuous, unbroken flow of information.
And just like the Sumerians, the Egyptians established these specialized archives, right?
Yeah.
Usually deep within palaces or temple complexes.
Yes, to centralize and safeguard this information. They were basically refining the centralized database and scaling it up.
But okay, put yourself in the shoes of a royal Egyptian administrator for a second.
Okay, I'm there.
You have this massive temple archive. It's a huge room, and it is filled with thousands upon thousands of rolled up papyrus scrolls.
Right.
And they all look exactly the same from the outside.
Just a wall of identical tubes.
Exactly. So if you need to find one specific tax decree from, say, a decade ago, how do you find it? You can't just hit Schuberl plus F.
You definitely cannot.
The sheer volume of data creates this massive retrieval problem. Storing the information is easy, but finding it again is a total nightmare.
Which naturally forces the next major leap in human innovation. Because as the volume of information scales up, the infrastructure required to navigate that information, it'd have to scale conceptually.
Right. And the Greeks provided two massive contributions to solve this retrieval bottleneck, didn't they?
They did. The first was the refinement of writing itself through the development of the alphabet.
Okay, let's unpack why the alphabet is such a massive technological leap compared to the older logographic or syllabic scripts.
So think of a logographic script like a massive uncompressed file format. In a pure logographic system, you need a unique symbol for almost every single concept or word.
Like thousands and thousands of characters.
Exactly. To be literate, a scribe has to memorize thousands of distinct characters. It's incredibly memory intensive.
Which means literacy is naturally restricted to a very small, highly trained elite.
Right. You have to train your whole life just to read the data. But the alphabet, on the other hand, is the ultimate form of data compression.
Because it takes thousands of symbols and compresses them down to, what, roughly 24 phonetic markers?
Precisely. You have this highly compressed code of 20-something symbols, and they can be infinitely rearranged to represent any sound, any word, any concept in the human language.
That's incredibly elegant.
It is. It's incredibly versatile,
Yeah.
and computationally much lighter on the human brain. This fundamentally democratized literacy.
It lowered the barrier to entry.
Exactly, which meant a wider segment of the population could suddenly generate, read, and record information. And more people writing means an exponential explosion in data generation.
Which brings us right back to the retrieval problem, only now it's like 10 times worse because everyone is writing.
Right, the data lake is overflowing.
If you have an explosion of alphabet-driven data, you need a better way to organize it. And that brings us to the second Greek contribution, which comes from a figure we usually associate with philosophy, not library science.
Aristotle.
Yes, Aristotle.
We always think of Aristotle pondering ethics or, the nature of the soul. But fundamentally, Aristotle was an information architect.
He was a data guy.
He really was. He pioneered methodologies involving detailed observation and rigorous logical categorization. He didn't just look at the world, he created a mental framework for how to group similar things together and how to separate different things.
He basically built the concept of the directory tree.
He absolutely did. Aristotelian logic introduced concepts like categories, genus, and species.
Okay, explain how that applies to data.
Well, he argued that to understand a thing, you must understand what broader group it belongs to and what specific traits differentiate it from other things in that same group.
So sorting things into folders and subfolders.
Exactly. This isn't just philosophical discourse. This is the logical syntax that future librarians would use to categorize the physical world of texts. He provided the conceptual blueprint for how to nest data.
Which leads directly to the ultimate application of that blueprint, right? The Library of Alexandria.
Yes, established in the 3rd century BCE.
And this wasn't just a giant storage warehouse for scrolls. It was a vibrant, active center of global scholarship. They were attempting to collect a copy of every single book in the world.
A truly global database.
They're literally pulling texts off ships in the harbor, copying them, keeping the originals, and giving the copies back to the sailors.
Which is pretty ruthless, but effective.
Right. The accumulation of global knowledge was unprecedented. But as we established, a massive pile of global knowledge is completely useless without a search engine.
Enter Callimachus.
Callimachus. Okay, let's unpack this guy.
Callimachus is arguably one of the most important figures in the history of information science. He was the one tasked with organizing this terrifying mountain of papyrus.
The system he developed was known as the Pinakes, right?
Yes, the Pinakes. It employed a highly sophisticated method of indexing and cross-referencing.
Okay, so wait. Did Callimachus essentially invent metadata and the hyperlink centuries before a computer was even a concept?
I mean, if we look at the actual mechanics of what he was doing, yes, absolutely.
That's wild.
Before Callimachus, archival practice was largely based on passive collection. You put the scrolls in a designated room, maybe grouped roughly by subject, and you just sort of hope the scholar can eventually hunt down what they need by unrolling scroll after scroll.
Just manually checking every file.
Exactly. Callimachus moved humanity from that passive collection to active, organized retrieval.
How did the Pinakes actually work in physical space? Like, what did it look like?
So the Pinakes were themselves a massive set of scrolls, essentially a master catalog. It was about 120 scrolls long.
Just the catalog was 120 scrolls.
Just the catalog. And Callimachus didn't just list titles. He categorized authors by genre. Poetry, philosophy, history, medicine.
Aristotelian categories.
Exactly. And within those genres, he alphabetized the authors.
Using the alphabet as an organizing tool, not just a writing tool.
Right. And for each author, he provided a brief biographical sketch, a list of their works, and this is the brilliant part, even the opening words of each text to ensure you had the right version.
Because books didn't have standardized titles back then.
Exactly. He was extracting key identifiers from the raw text and organizing them in a separate, abstracted layer.
He was creating data about data. That is the exact definition of metadata.
Yes. And by doing this, he implemented Aristotelian logic into a physical data set. When modern computer scientists design relational databases, where tables of data are linked by common identifiers,
right,
they are utilizing the same logical architecture Callimachus deployed in Alexandria. If you wanted to find a specific play by Euripides, you didn't wander the halls looking at thousands of scrolls.
You consulted the abstraction layer.
You checked the index. The index pointed you to the physical location of the data. Callimachus proved that to manage information effectively at scale, you need a map that sits above the territory.
It is just a stunning intellectual peak. You have this vibrant center of scholarship, a beautifully cross-referenced analog database running on Aristotelian logic, processing a massive volume of alphabet-compressed data. Humanity had figured it out.
They really had a working system.
But of course, just as this incredible system was humming along, history throws a massive, catastrophic curveball.
The fall of Rome.
The Western Roman Empire collapses.
And the collapse of the political, economic, and physical infrastructure of the Roman Empire was just devastating for the preservation of knowledge.
If we stick with our technology analogies, the fall of Rome was essentially a massive continent-wide server crash.
That's exactly what it was.
The power grid goes down. The institutions that funded and protected these massive centralized libraries completely disintegrate. The centralized database model fails.
It fails completely.
So the burning question is, How did humanity's data survive this fragmented, chaotic aftermath?
Well, it was a period of intense precariousness. The classical libraries were largely lost, they were destroyed by conflict, or they were simply abandoned to rot. But the preservation of a crucial portion of this data fell to a completely different type of institution.
Some monasteries.
Yes. Following the fall of the Western Roman Empire, the flame of learning was kept alive within the fortified walls of monastic communities. The monasteries became the new, decentralized data centers of Europe.
And the monks were the processors.
Exactly.
The sources describe the scriptorium, right? This dedicated room within the monastery where monks labored to hand copy manuscripts. When I picture a scriptorium, I see an excruciatingly slow, agonizing process of manual data migration and backup.
That is a very accurate picture.
Without a printing press, without a central authority, the only way to ensure the data survived the server crash of the Dark Ages was to physically write out every single letter, every single word, over and over again, onto parchment or vellum.
And the physical toll of this cannot be understated. Monks worked in unheated rooms, in absolute silence, using quill pens and ink they had to mix themselves. They were copying texts in the freezing cold until their hands cramped and their eyesight failed.
It was an act of extreme endurance.
It really was. But it's vital to realize that these monastic libraries were not just passive storehouses, and the monks were not just blind copy machines.
They weren't just hitting copy-paste.
No, the copying process itself served as a profound form of intellectual engagement.
They were actively grappling with the code they were copying.
Yes. They were reading, interpreting, correcting what they perceived as errors, and preserving.
Yeah.
But in doing so, they fundamentally altered the metadata.
The filing system changed.
Massively.
The overarching logic of the library shifted entirely.
It did. The classification systems developed by the monks shifted heavily toward theology. The primary purpose of a monastic library was spiritual development. Therefore, Bibles, liturgical texts, commentaries by the church fathers, and lives of the saints took absolute precedence.
So the categorization was no longer based purely on Aristotelian logic or classical genres like comedy and tragedy.
Like the dominant sorting algorithm became spiritual utility.
So what happened to all the classical data? The
Yeah.
philosophy, the astronomy, the plays, did they just delete it?
And this is the crucial, fascinating dual nature of the monastic era. They did preserve classical works of philosophy, science, and history. The monks recognized the immense intellectual value of antiquity.
Yeah.
But they often reinterpreted them or organized them through a moral or theological lens. For example, a text on ancient astronomy might be preserved, but only because it was deemed useful for calculating the date of Easter.
Ah, I see. So they saved the classical data, but they applied a completely new ideological filter to the search engine.
That's a perfect way to put it.
They maintained the hardware of knowledge, the physical books, even as they reconfigured the software of how that knowledge was categorized and understood.
Precisely. And this monastic, decentralized system functioned for centuries. But as Europe stabilizes and moves into the High Middle Ages, around the 11th and 12th centuries, the architecture shifts yet again. We see the rise of universities.
Places like Bologna, Paris, Oxford.
Yes, and this introduces a major structural change in how knowledge is handled.
The sources mention that university academic libraries were distinct from the monastic collections, and they created separate collections for different faculties, right? Like law, medicine, theology, and the arts.
Which is a massive conceptual leap. Think about it. If the monastery was one giant centralized theological database, the university introduced the concept of domain-specific databases.
Okay, yes. When you design a complex digital system today, you don't dump all your data into one undifferentiated data lake if you want it to be efficient.
No, that would be incredibly slow to query.
Right. You create specialized databases optimized for particular types of queries. A database for searching medical imaging operates on completely different parameters than a database for searching legal precedents.
And the medieval universities were pioneering this exact concept in the physical world. They realized that the sheer volume of specialized knowledge required different organizational structures.
Because law students needed rapid access to Justinian's legal codes and commentaries.
Exactly. They didn't need to wade through hundreds of theological tracts just to find a property law precedent. The universities physically separated the data to optimize retrieval for specific user bases.
Which makes total sense.
Furthermore, this increasing demand for specialized texts among a growing student population spurred the development of a professional secular book trade. Professional scribes and illuminators set up shop near universities to meet a demand that the monastic scriptoriums alone could no longer satisfy.
But, I mean, even with professional scribes working full-time, you still have a massive physical bottleneck.
Hand copying is the ultimate limitation on bandwidth.
It takes months, sometimes years, to reproduce a single complex dataset. It keeps the total volume of information in society artificially capped. Now, I want you to imagine what happens when a machine is invented that shatters that bottleneck overnight. What happens to a society and to the people tasked with organizing knowledge when the bandwidth limitation is suddenly, violently removed?
It creates an existential crisis for information architecture.
We are, of course, talking about the mid-15th century and the invention of the printing press by Johannes Gutenberg.
The printing press is arguably the most recognizable turning point in the history of information dissemination.
Without a doubt.
For the first time, books could be produced in large quantities, rapidly and relatively inexpensively. The sources refer to this as a democratization of knowledge, fostering wider literacy and intellectual curiosity across Europe.
Okay, here is where the traditional historical narrative needs some serious pushback.
I agree.
We always praise the printing press. We look at it in hindsight as this pure, unalloyed triumph of enlightenment, freeing knowledge from the elite and bringing books to the masses. But at the exact moment it happened, didn't this massive, sudden influx of data actually cause history's first major crisis of information overload?
Yes, absolutely. People actually panicked.
Wait, really?
Oh, yeah. It wasn't seen as a pure triumph by everyone. To many scholars and librarians at the time, it was an absolute nightmare.
We were stressed out.
Very. There are historical records of early modern scholars complaining that the abundance of books was a distracting nuisance. They literally thought society would drown in text.
The printing press scaled information so aggressively that the traditional medieval library systems completely broke down.
It's the equivalent of going from receiving a trickle of 3 emails a day to receiving 10,000 emails a day. But you have no search bar, no spam filter, and no folders.
Imagine you're a university librarian in 1460. You're used to accessioning maybe 1 or 2 new, highly expensive, hand-copied manuscripts a year.
You know exactly where they go. You know every single book in your room.
Right. Suddenly there's a printing press in the city and you're receiving 50 new books a month, then 500 a year.
Your entire mental filing system collapses.
Your physical shelves, your domain-specific databases, they all undergo complete systemic collapse.
The sheer volume of printed material forced radical innovation in cataloging. When books were rare, a thematic or theological arrangement worked fine. When thousands of new titles flood into academic centers, you need a more scalable algorithm.
So what do?
This crisis necessitates the emergence of early printed alphabetical catalogs, replacing the older thematic arrangements.
Going back to Callimachus's trick.
Exactly. Alphabetical sorting becomes the essential algorithm for managing scale. And as massive national libraries began to form, like the Bibliothèque Nationale in France, society had to invent entirely new administrative tools just to track what existed.
Which brings us to the Enlightenment era, and a monumental project that tried to wrangle this chaos. Denis Diderot and Jean-Laurent D'Alembert's Encyclopédie.
A fascinating project.
Now, when we hear encyclopedia, we usually think of a dusty set of heavy books we used for middle school research before Wikipedia existed. It seems quaint.
It does.
But we need to view it through the lens of information architecture, right?
Absolutely. Diderot's Encyclopédie, published in the mid-18th century, is a crucial conceptual milestone. It was not just a reference book. It was a monumental, audacious attempt to synthesize and classify all human knowledge based on a specific algorithm.
And what was that algorithm?
Reason. During the Renaissance and Enlightenment, the scientific revolution had shattered old paradigms, leading to the creation of entirely new knowledge domains. We're talking physics, advanced mathematics, new branches of biology, mechanics, economics.
That data was expanding in every direction.
Yes. Diderot and D'Alembert were attempting to map these expanding chaotic domains systematically.
They were trying to build a static, physical version of a master digital database. They were literally mapping the internet's search index onto paper.
That is the exact logical framework.
Yeah.
They even included a famous tree of human knowledge in the encyclopedia, which was a literal map of how different disciplines connected to one another.
Like a physical visualization of a directory tree.
Precisely. The encyclopedia proves a fundamental rule. Humanity's desire to categorize and map knowledge scales directly alongside our technological capacity to produce it.
The printing press created the data explosion, and the encyclopedia was the analog attempt to reestablish control and order over that data.
It was an ambitious project to map the entire universe of human understanding, basically replacing the old theological sorting algorithm of the monks with a new rationalist sorting algorithm.
It's a brilliant effort, truly. But an encyclopedia has a fatal flaw, doesn't it?
It's static.
Exactly. It is only a snapshot in time. It is a static map. It's great for synthesizing knowledge up to the exact date it goes to the printer. But as the centuries ticked on into the 19th and early 20th centuries, the printing press just kept churning.
And getting faster.
Right. The Industrial Revolution mechanized the printing press. Steam-powered presses were spitting out daily newspapers, scientific journals, government reports, novels, pamphlets.
The data was compounding at an exponential rate.
There was simply too much printed material for any single book or even a massive 28-volume encyclopedia to synthesize.
The scale became utterly impossible for any human mind to encompass. Society needed new tools. We needed a way to peek inside the books, to evaluate their contents, without having to actually read them cover to cover, just to see if they were relevant to our research.
And this brings us to the immediate precursors of our modern digital systems, the development of advanced indexing and abstracting services in the 19th and 20th centuries.
A crucial development.
As the volume of printed material swelled, researchers and librarians realized they needed much more granular access points. The sources emphasized that indexes located specific information within texts, while abstracts provided concise summaries of entire documents.
Think about how an abstract physically worked before the digital age. A scientist publishes a 50-page paper on chemistry. Another specialized service reads that paper, condenses its findings, methodology, and conclusions into a single paragraph, and publishes a journal containing nothing but these abstract paragraphs, organized by subject.
It is exactly like the snippets and the blue links on a modern Google search results page.
It really is.
They essentially invented the TLDR too long, didn't read.
That's hilarious, but accurate.
They created a highly compressed proxy of the data so researchers wouldn't waste weeks of their lives reading full text that had nothing to do with their actual query.
It's a mechanism to reduce friction in information retrieval. These abstracting techniques were absolutely vital for navigating the rapidly expanding landscape of published knowledge. But it wasn't just about finding things in books, you know?
Right, there were other types of records.
Yes, the 19th and 20th centuries also saw the rise of entirely new types of massive collections that needed managing.
The sources highlight the rise of specialized and national archives during this period. We're talking about massive, sprawling repositories dedicated to specific areas. Government administrative records, historical documents, census data, military records.
Basically, the entire bureaucratic output of modern nation-states.
And as these archives grew to sizes that would have made the ancient librarians of Alexandria weep, the ad hoc methods of the past were no longer sufficient.
No, you couldn't just invent a system on the fly anymore.
This era saw the strict formalization of archival science. This wasn't just a matter of putting boxes on shelves and writing a label with a Sharpie.
Far from it. Archivists developed highly rigorous, standardized, algorithmic methods for handling information.
The sources specifically list the core pillars of this new science: accessioning, appraising, arranging, and describing collections.
And these pillars are fundamental.
I want to break those 4 pillars down in excruciating detail because when you look closely at them, they sound unbelievably relevant to how we handle digital data today. Let's start with accessioning.
Okay, accessioning. This is the formal, legal, and physical process of accepting data into a system. When a massive load of documents arrives in an archive, you don't just put it on a shelf.
You don't just dump it in a room.
No, you accession it. You establish baseline control. You record exactly where it came from, when it arrived, who owns it, and its general physical condition. It is essentially a quarantine zone for incoming data before it is integrated into the main system.
That is exactly what happens when a cloud server ingests new files.
It is the exact same process.
It checks the file type, it logs the upload timestamp, verifies the user permissions, and establishes a baseline registry of the data before moving it into active storage.
Yep.
Okay, what about appraising?
Appraising is arguably the most brutal and important part of an archivist's job. It is evaluating the data to determine its long-term value. An archive cannot keep everything. They would physically drown in paper.
So they have to make cuts.
The archivist must decide what is historically or administratively significant enough to keep and what must be purged or destroyed.
They are managing server space, they are deleting the temp files, the duplicates, the junk data, so the system doesn't crash under its own weight.
Exactly. It's active data curation.
Okay, next pillar. What is arranging?
Arranging is establishing the physical and logical structure of the data based on its origins. In archival science, there is a principle called respect des fonds, which means you keep records together based on who created them, rather than shuffling them all into one giant alphabetical subject file.
Why does that matter?
Because you must maintain the original directory tree of the creator. The context of how the files were grouped provides essential information. A letter means something different depending on which folder the creator put it in.
So if a government agency uploads its files, the archive maintains the agency's internal folder structure. Folder, subfolder, file. Just like navigating a hard drive.
Exactly. It preserves the structural metadata.
And finally, describing.
Describing is the creation of detailed finding aids, catalogs, and indexes so that users can actually locate the information within those arrangements. It is the intensive generation of metadata dates, subjects, file sizes, keywords applied to the arranged data.
So making it searchable.
Exactly. Furthermore, this period gave birth to the distinct academic field of information retrieval, where researchers actively studied the mathematical and logical efficiency of how to query these systems.
When I look at those 4 pillars, accessioning, appraising, arranging, describing, I don't just see a librarian in a dusty basement with a cart of manila folders.
What do you see?
I see the exact logical parameters programmed into modern database management software. When you drag and drop a file into a cloud drive, the software ingests it, assesses its metadata, sorts it into the directory tree you've arranged, and generates searchable tags so you can find it later.
It is doing all of that automatically.
The software is literally just executing the rules of 19th century archival science.
And that is the profound core insight we can extract from these sources. The physical manual systems meticulously developed by librarians and archivists in the 19th and 20th centuries laid the precise groundwork for the automated digital systems we use today.
It wasn't a sudden invention in Silicon Valley.
No. The meticulous efforts in classification, the creation of indexes, the structuring of specialized archives, the rigorous rules of accessioning, these were not merely exercises in organizing paper. They were the intellectual foundation of the Internet.
That is just wild to think about.
The physical era was, quite literally, writing the logical source code for how the digital era would function. The computers just automated the manual labor.
So let's zoom out and summarize this incredible, sweeping journey we just took. We have traversed a massive expanse of human history to understand why our digital world looks the way it does today.
We covered a lot of ground.
We started with the Sumerians, laboriously baking clay tablets in Mesopotamia, creating the first physical hard drives to centralize administrative power and invent the database.
The first data silos.
Right. Then we moved to the Greeks, where the data compression of the alphabet caused an information explosion, forcing Aristotle to invent logical directory trees and Callimachus to invent metadata and cross-referencing among the scrolls of Alexandria.
Setting up the master catalog.
We saw the catastrophic server crash at the Roman Empire and watched the monks of the Middle Ages step in as decentralized human processors, manually backing up classical data while applying a new theological sorting algorithm.
Keeping the data alive.
To witness the rise of universities creating the first domain-specific databases, we felt the sheer panic when Gutenberg's printing press shattered the bandwidth bottleneck, causing a flood of data that overwhelmed the old systems and forced the invention of modern alphabetical cataloging and Diderot's encyclopedic attempt to map all human knowledge.
The first real information overload crisis.
Exactly. And finally, we arrived at the modern era, where the crushing weight of the industrial printing press necessitated the invention of abstracts, the ultimate TLDR, and the formal, rigorous rules of archival science, accessioning, appraising, arranging, and describing.
It's a continuous, unbroken chain of innovation.
Every single time our physical hardware evolved, from clay to papyrus to parchment to paper, the resulting flood of data drove incredible intellectual innovation in how we organize knowledge.
And the relevance of this history to your daily life cannot be overstated. Every single day, you interact with the ghosts of these ancient archivists.
They are everywhere.
Whenever you type a query into a search bar, Whenever you organize the folders on your desktop, whenever you apply a tag to a photograph on your phone, or whenever you skim an article's summary to see if it's worth your time, you are actively participating in a 6,000-year-old tradition of information retrieval.
You are part of that legacy.
The digital world that surrounds you is not a clean break from the past. It is simply a high-speed, automated reflection of the ancient library. The challenges you face with information overload today, that feeling of drowning in your inbox, are the exact same conceptual challenges faced by the scribes in Mesopotamia, the frantic scholars of the Renaissance, and the meticulous archivists of the 19th century.
Which leaves us with a fascinating and maybe slightly unsettling final thought to mull over. The sources have shown us that our modern digital networks operate on the exact same logic that was invented for physical paper and scrolls.
The exact same logic.
The technology is infinitely faster, but the fundamental rules of categorization are ancient. This raises a provocative question for you to explore on your own. Our current cutting-edge artificial intelligence-driven technology is still functionally organized by the legacy rules of the physical world.
Right, the 19th century rules.
But as our data becomes infinitely complex, as AI begins to generate more data in a single day than humanity produced in an entire century, what happens when we finally reach the limits of those centuries-old categories?
That's a great question.
Are we truly maximizing the potential of the digital age, or are we just running the Library of Alexandria at the speed of light, waiting for the system to break?